Welcome to lesson 1.3. So today we're going to talk about the midpoint formula and distance formula on a coordinate plane. So you kind of talked about midpoint on a line segment, so now we're kind of going into, okay, what happens when we're on the coordinate plane? But we're first going to start with the distance formula. So if you look right here, we have two ordered pairs right here and right here. We have AB and CD, okay? So when you have 2 points like this, all you have to do is label them. So A is your X value, right? And B is your Y value. C is your X value, D is your Y value. Now you're going to label them 1 and 2. So set 1 and set 2. So X1, Y1, X2, Y2. Okay, so the distance formula is the distance equals the square root of x2 minus x1 squared plus, sorry, let me rewrite that because I'm out of room. The distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so that's the distance formula, and so that's what we're going to use. So we're going to go inside the inside the foldable and do that part first. Okay, so if you look in here, we have these points A, B, and C on this graph right here. So let's first decide where A, B, and C are. So A is at 4, 6. C is at -3, -8. And B is at -8, 4. So if they want the distance of AB, so they want the distance from A to B, so from here to here, that's what they're wanting, from B to A or A to B. Okay, and we're going to figure that out right here. So first things first is we need what A is. So A is 4, 6, and B is -8, 4. So the first thing we're going to do is label x1, y1, x2, y2. It doesn't matter which one you do, you just have to make sure you're consistent. Okay, so x1, y1, x2, y2. So we have the distance is the square root of x2, so -8, minus x1, 4 squared, plus y2, so 4, minus y1 squared. Okay, so then we're going to subtract. So -8 minus -4 is -12 squared, plus 4 minus 6 is -2 squared. So remember, you can do this part in your calculator. That is totally fine with me. So that equals 144 plus 4. And then that is 148. So the distance is the square root of 148, and we can simplify that radical to 2 square root 37. Okay, so the distance from B to A is 2 square root 37. Okay, so then we want to find the distance from B to C, so from here to here. And so in order to do that, we need to first label the coordinates. So B is -8, 4. C is -3, -8. So x1, y1, x2, y2. Okay. So the distance is the square root of x2, so -3 minus -8 squared, x2 minus x1, plus y2, so -8 minus y1 squared. Okay, so then -3 minus -8 is going to be 5. because remember, when you're subtracting a negative, you're adding a positive. And negative 8 is squared is 12. So then that equals the square root of 25 plus 144. So that is the square root of 169, and the square root of 169 is 13. So the distance from B to C is 13. Okay? And then the last one, CA, so they want us to find the distance from C to A. And to do that, we're doing the same process. We take the two coordinates, so -3, -8, and A is 4, 6. We're labeling them x1, y1, x2, y2. And what we're going to do is plug it in. So the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's the square root of 7 squared plus 14 squared, which is the square root of 245. So if you squared those and added them, you get 245, and that simplifies to 2 square root 35. Okay, so that's finding the distance of 2 points. So you just label them x1, y1, x2, y2, and you plug them into the formula, and you simplify the radical. Okay, then for midpoint I think is a little bit easier to do. So first and foremost, you still label them the same way. So x2, x1, y1, and then x2, y2. Remember, distances from A to B, the midpoint is like what is that point that's in the middle of that? Okay, so to find the midpoint, MP is equal to x2 plus x1 divided by 2, and y2 plus y1 divided by 2. So that's how you find the ordered pair, because remember, ordered pair is x values and y values. And then to find the endpoint, this is going to be a little confusing, like using all the x's and y's, but once we do one, it probably won't be so bad. So endpoint, midpoint, and the other endpoint. So we have two endpoints. Think about that. Align point A to point B. Okay, so we're going to label this as, okay, if I have x1, y1, and x2, y2, and x3, y3, and this one is missing. So I have the midpoint and I have the endpoint. Then what you would do is you'd set it up as x3 equals x2 plus x1 divided by 2, and y3 is equal to y2 plus y1 divided by 2. Then you would just solve for x2 and solve for y2. Okay, so that's kind of the formula. You'll understand that a little better once we do an example. So let's go into the thing. So we want to find, MP just stands for midpoint. So we're finding the midpoint of AB. Now you can kind of guesstimate that where it is, but we're actually physically going to graph where it is. So we have A is, remember, 4, 6, and B is -8, 4. So again, x1, y1, x2, y2. So then we're going to plug it in. So I have the ordered pair. So x2, so -8 plus x1, 4, y2, 4, plus y1, 6. Okay, negative 8 plus 4 is negative 4. 4 plus 6 is 10. Negative 4 divided by 2 is negative 2, and 10 divided by 2 is 5. So that's our midpoint, negative 2, 5. And if you go on the graph, that's right here. So that point is the midpoint of AB. Okay, it's just saying where is the middle from A to B. Okay, so MP of BC, B is negative 8, 4, and C is negative 3, negative 8, so x1, y1, x2, y2. So negative 8 plus negative 3 divided by 2, negative 8 plus 4 divided by 2, so negative 11 over 2, negative 4 over 2, and that simplifies to negative 5.5 and negative 2. So now we're going to graph that. So from B to C, the midpoint is negative 5.5, 2. So right here, that ordered pair. That's the midpoint of BC. Okay, and then CA, so C is negative 3, negative 8, A is 4, 6. So again, x1, y1, x2, y2. You just keep labeling them. Okay, so then, let's see, 4 plus negative 3 divided by 2, negative 8 plus 6 divided by 2. Then that's going to be 0.5, and negative 8 plus 6 is negative 2 divided by 2 is negative 1. So our midpoint is 1/2 negative 1. So we're going to graph that. So 1/2 negative 1, and that would be right here. So those are the midpoints on that graph. Okay, so the midpoint is literally where is the middle between the 2 points. Okay, and then the last 2 problems. So if one endpoint of the line segment is negative 8, 10, and the midpoint is 10, negative 6, find the other endpoint. So I have an endpoint of, so EP is negative 8, 10, and the midpoint, MP, is 10, negative 6. So essentially we're going to reuse something like this, but kind of set it up a little differently. So we know the midpoint is 10, negative 6, right? So what that means is that negative 8 plus the x value is going to be 10, right? Then negative 10 plus the y value is going to be the midpoint of negative 6, because that x and y is representing the other endpoint. Because in the formula, we just add the endpoints. Well, we don't know the endpoint. So now we're going to solve for x and y. So negative 8 plus x divided by 2 equals 10. And then 10 plus y divided by 2 equals negative 6. Okay. So then we're going to multiply by 2. And so when we do that, I'm sorry, I'm running out of room, so I'm going to have to erase some of this. We end up with negative 8 plus x equals 20. And then 10 plus y equals negative 12. Okay, so that's just me multiplying both sides by 2. And then I'm going to add 8, so x equals 28. And y equals negative 22 because I subtract 10. So the other endpoint, so what I'm missing, that is going to be the x value is 28 and the y value is negative 22. Okay, so that's how you find the endpoint if you have a midpoint and the other endpoint. So let's do the next one. So the endpoint is 9, 7, 9, negative 7. okay? And the midpoint is 0, -1. So I know that 9 plus x and -7 plus y divided by 2 is equal to the midpoint, 0, -1. So now I'm going to set those equations. So 9 plus x divided by 2 equals 0, and -7 plus y divided by 2 equals -1. So 9 plus x equals 0, so x equals -9. Then -7 plus y equals -2, so y equals 5. So the other endpoint is -9, 5. So that's it for this video. Bye.